All right, let's continue on with a little bit more complex identities, or to simplify by expanding and using identities, as the title says. Looking at the start of this, we got to think, what does that mean in the numerator right there? What am I going to do with that? Because I don't have an identity that has just a single secant in it with a minus or plus one. And when I look at that, I go, but I do have something with secant squared. So if you can recognize that this numerator is a difference of squares, we can then work that out. So it's a difference of squares. It's like saying x plus 1 times x minus 1. Well, that would be x squared minus 1 when you multiply it out. If you're not terribly sure, FOIL it or use the distributive property and multiply it out. But what that would give you secant squared x minus 1. That's what it's going to give you when you multiply it out, because secant times secant is a secant squared. And then secant times 1 is just a secant x, and then a negative 1 times secant x is a negative secant. Well, a positive secant x and a minus secant x will get rid of the middle term. And then a negative 1 times a positive 1 is a negative 1. That's all over sine squared x. Okay, remember we're thinking puzzle. What else can I do at this point? Well, the numerator is an identity. That is a Pythagorean identity. And let me just pull that over to show you again what the identities were. So over here, here's our Pythagorean identities that we came up with in our other video. And secant squared x minus 1. Well, my secant squared is equal to 1 plus tangent squared, or theta x, whatever it is. It doesn't matter if you use theta or you use a variable. Well, if I subtract 1 to the other side, I have a tangent squared theta equals secant squared theta minus 1. That is the exact same thing as this numerator. It doesn't matter the variable, or if you use theta, a Greek letter, or if you use the variable x, it means the same thing. The basic identity is still there. Well, that would be tangent squared. So I'm going to have that as tangent squared x over sine squared x. Now we're looking a little bit nicer because we know what tangent squared x is. Remember, our tangent is our sine over cosine. Well, I have sines and I have tangents. I'm going to simplify my tangent so it's all in the same type of item. So I'm going to use a quotient identity in the numerator. And what I would have is this being, well, tangent squared x is the same as sine squared x over cosine squared x. And that's still over sine squared x. Nice. Now I have a fraction inside of a fraction. So I can go, oh, sine squared x is the same as that over 1. And I would have copy dot flip or multiply by its reciprocal. And that would take the numerator, sine squared x over cosine squared x, times this flip side or reciprocal is 1 over sine squared x. Oh, so nice. I have two items, one in the numerator, one in the denominator, exactly the same. They can simplify out, be 1. And then I have, okay, this is 1 over cosine squared x. Then I think, what did I start in? I had secants and sines. So if I'm in a fraction and I can get that back to just one item in the numerator, then we do that. So we're going to go ahead, and I know 1 over cosine is secant. So 1 over cosine squared is secant squared. So secant squared, and in this case it's x. If it was theta, we would have theta. It's whatever variable or Greek symbol it's going to use to represent that piece. All right, let's do another. Simplifying by combining fractions and using identities. Again, it's just making sure that I can deal in fractions. So think about that as 1 over 2, so 1/2 minus 1/3. I have to get a common denominator before I can subtract fractions. And if it's 1/2 over 1 and 1/3, my common denominator would be 6. So let me just write that off to the side. Think about 1/2 minus 1/3. I would need a lowest common denominator would be 6, or in this case, 2 times 3. And then you would multiply each side by what it's missing. Well, think about it in simplified form before you go to the trig. Well, this is a binomial. It's really handcuffed. I can't separate that yet. I have two independent things. I have 1 minus sine x and I have cosine x. There's nothing in common, so I know that my LCD is going to be 1 minus sine x times cosine x. Not bad. Okay. That means on the left-hand side, I'm going to be multiplying by cosine x, and on the right-hand fraction, it's going to be 1 minus sine x. So let's do that. I have cosine x over 1 minus sine x, and I'm going to have to multiply that by its cosine x over cosine x, because that's going to give me the common denominator. Now on the right-hand side, I have sine x over cosine x, and I have to multiply by my 1 minus sine x to get my lowest common denominator. Whatever I do to the denominator, I do to the numerator, and to get that. Okay, so what happens with these? Well, left-hand fraction, just multiply the numerators. I have cosine times cosine. That's cosine squared. So I have cosine squared x on the first numerator, and on the denominator, I have cosine x times 1 minus sine x. I'm just going to leave it as that right this moment. And then on the right-hand side, I'm going to go ahead and multiply it through. So use the distributive property and multiply it out. And I have sine x minus sine squared x. Remember, this is just multiplying this piece, not including the negative. I have not distributed the negative through it yet. All over cosine x times 1 minus sine x. Okay, let's go ahead and condense this a little bit more. I'm going to go ahead and move it over a little bit here. So I'm going to have in the numerator cosine squared x, take the negative and now distribute it through. And I have a minus sine x and a plus sine squared x, all over its common denominator of cosine x times 1 minus sine x. Now you may ask, why not distribute the denominator out? Why not multiply that out? Well, that goes back to our rationals and just a simplifying method, that what we're going to do is we're going to combine like terms, do whatever we can in the numerator, and then we try to factor it back out and simplify again. So knowing that, I'm not going to need to multiply this out. It's not going to help us in any means. It won't change the identities. There's no cosine minus sine identity. And I may be able to simplify something in the numerator and denominator in a moment. So leave the denominator as is. Just do the numerator and condense it down, simplify it, and then refactor. So let's do that. Now look at why don't I rearrange the numerator? Let me put my squares together. So cosine squared x plus sine squared x minus sine x all over cosine x 1 minus sine x. Now our identity, our basic identity from the unit circle took this piece, that's an x, the same as saying x squared plus y squared was equal to 1. Well, now I showed you in the previous video that cosine squared x plus sine squared x equals 1. Or you can say sine squared x plus cosine squared x equals 1. So let's replace this. This is an identity right here, and it is 1. So I have 1 minus sine x all over cosine x times 1 minus sine x. Do you see that it's now going to be super nice to simplify? Remember, these are being multiplied. Simplification is really division, so that's the inverse of multiplication. So it's fine to say this can be handcuffed now if you want to think about it as a binomial, handcuffed, and I can go, okay, I now know that anything divided by itself, even if it's a binomial, is the same as 1. So I get that reduced down to 1 over cosine x. Well, yes, I did start in cosine and sines, but can I simplify it to just being something in the numerator and not in fraction form? I can't. So let's go ahead and do that. Cosine, 1 over cosine is the same as secant. So this becomes secant x. I love these puzzles. These are so much fun. You just have to think about what can I do? It's thinking, forward thinking, and deductive reasoning skills. I hope you enjoy them and have a good one.